Shen Stars. How are you all? I hope you are doing well at your home. Students, today we are going to complete our exercise 6.5 and for the next we are going to revise the same. Question number 14 is the perpendicular from A on the side BC of a triangle ABC intersects BC at D such that BD is equal to 3 times CD. Then prove that twice of AB square is equal to twice of AC square plus BC square. Students, because there is square which is needed to be proved, so that means we are going to use the Pythagoras theorem. So let us start with the proof. In triangle ACD, AC square will be equal to AD square plus CD square. So this implies AD square will be equal to AC square minus CD square. Similarly, in the triangle ABD, AD square will be equal to AB square minus BD square. So we will compare the value of AD square from both the triangles. So we are getting the value as AC square minus CD square is equal to AB square minus BD square. Now we can substitute BD, that is DB, as 3 times CD. So let us do that. So students, as we are given with that BD is equal to thrice of CD, so that means we can write CD and BD in terms of BC. So DC will be comprising of 1/4 of BC, whereas BT will be equal to 3/4 of BC. So we are going to substitute these values of CD and BD in the above equation. So it will reduces to AC square minus BC square by 16 and is equal to AB square minus 9 times of BC square by 16. So next we are going to take the LCM and we will cross multiply the values. So when we take the LCM, we are getting 16 AC square minus BC square is equal to 16 AB square minus 9 BC square. Next we are going to cancel the common terms and combine the rest. So here we are getting the value as 16 AC square is equal to 16 AB square minus 8 BC square. As you can see that 8 is common between the whole equation, so we are taking out the 8 common and cancelling it out. So we will get the required result. Students, next question number 15 is in an equilateral triangle ABCD, D is a point on BC such that BD is equal to 1/3 of BC. Then prove that 9 times of AD square is equal to 7 times of AB square. Since it is an equilateral triangle, so all three sides of this triangle will be equal. Again, you can see in the to proof part that we require only AD and AB. So we have to replace BD in terms of BC and BC can be replaced in terms of AB. So let us see how the proof is. In this triangle, we are drawing an altitude, say AE, on BC. Why we are drawing the altitude? Because we know that Pythagoras is applicable only in a right angle triangle. And how we come to know that we are going to use the Pythagoras? You can see from the to proof part that we require AD square and AB square, and square comes only in the case of Pythagoras. So here how we will going to do the question. So students, we can take BE and EC as A/2. We are considering the every side of this triangle as A. Why we are taking BE and EC is equal to A/2? Because this is one of the property of the equilateral triangle that its altitude and median are the same. So from here AB square will be equal to AE square plus BE square by using Pythagoras. So it reduces to A square is equal to AD square plus A square by 4, which implies we are getting AD as root 3A/2. Further, we are given with that BD is equal to 1/3 of BC. So this implies BD will be equal to A/3. DE is equal to BE minus BD, that you can see from the figure. So that is A/2 minus A/3, that is equivalent to A/3. Now In triangle ADE, we are using the Pythagoras theorem. We are getting AD square as AE square plus DE square. So we will substitute both the terms in the value of A. So AD square reduces to A root 3 by 2 whole square plus A by 6 whole square. On simplifying this, we are getting 3A square by 4 plus A square by 36. On taking LCM, we are left with 28A square over 36. On cancellation, we are getting 7 by 9 A square. So this implies AD square is equal to 7 by 9 of AB square. Cross multiply this 9 to the AD square. So we are getting 9 times of AD square equal to 7 times of AB square, which is the required proof. Now students, question number 16 is, in an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of its altitude. So that means we need to prove that AB square is equal to, or you can say 3 times of AB square is equal to 4 times of AE square. So in this triangle, first we will draw the altitude, say that is AE, which is perpendicular on BC. Again we will use that special property of an equilateral triangle, that its altitude and the median are one and the same. So we are using the Pythagoras theorem in the triangle ABE. So here AB square will be equal to AE square plus BE square. So let us take each side equal to A. So that means A square equal to AE square plus A square by 4. On simplifying this, we are getting 4 times of AE square equal to 3 times of A square. So that means 4 times of the altitude is equal to 3 times of the side, which is the required proof. Next, question number 17 is, tick the correct answer, justify. In triangle ABC, AB is equal to 6 root 3, AC is equal to 12 and BC is equal to 6. The angle B is, students, here we are going to check whether the values of AB, BC and AC makes the Pythagorean triplet or not. If they are, then angle B is 90, otherwise it is not. So do try this question by yourself. That's all for today, students. Do revise what we have done in the class today and do your homework also. Thank you so much, students. Take care and have a great day ahead.